Hello everyone, my name is Jessica Perez, and today I will be explaining to you Chapter 2, Problem 2 from the textbook. So the question states, if the magnitude of the resultant force is to be 500 newtons directed along the positive y-axis, determine the magnitude of the force and its direction theta. So first we start out by identifying our givens, which would be the force of the resultant, which is 500 newtons, and we are going to label that on the drawing over here. Fr equals 500 newtons. In addition, we are given F1 equals 700 newtons, and we can label that on the drawing F1 over here. And we're also given an angle between the x-axis and the third quadrant, which is 15 degrees. This then leads us to step 2 of the problem, which is to determine what we are going to find. And for this problem, it would be to find the magnitude and the direction of the force. Step 3 would be to make assumptions, and these assumptions would be on how we would assume to solve the problem. For this problem, from the drawing, we identify that these forces make triangles within their quadrants, and that would lead us to use the law of sines and cosines to solve. Therefore, that leads us into our plan of drawing a free body diagram and labeling the sides for the angle. In addition, that will lead us to use the law of cosines to solve for the force and the law of sines to solve for the angle. Then we would draw our free body diagrams. So what we're going to do is draw an axis. And from the problem, we see that a force is going in this direction, and force 1 is going over here, F1, and then we are going to label the 15 degrees between the axis, and then the resultant force, which is positive along the y-axis. We can say Fr. And we're going to say this equals 500 newtons, whereas F1 equals 700 newtons. 700 newtons. And then this is theta, what we're solving for. We're solving for this F. And we're going to draw the triangles. And their similar angles. To further prove that this is a law of cosines problem, we're going to draw one of the triangles over here and label it. So right here, this is going to be 700 newtons. And this side will be 500 newtons. And the angle in here is 105. How we get 105 is this is A over here. So, and A is going to be alternate interior with this over here, and that it would be 90. A equals 90 plus 15, which is 105. So it's an alternate interior angle. After drawing these diagrams, we can see that we have to use the law of cosines to solve for the force, which would be step 6 in our solution. So to acquire our solution, we have to use the law of cosines, which is c equals the square root of a squared plus b squared minus 2ab cosine y. Or cosine a, we'll put that in parentheses. So we're going to have f equals the square root of 500 squared plus 700 squared minus 2 times 500 times 700 times cosine of 105, and let's extend this. So calculations, we determined that the force equals 960 newtons rounded. And now we're going to determine what theta is using the law of sines. So sine of 90 plus theta over 700 equals sine of 105 over 959.78, which is the force of not rounded to give us a more precise answer, and that would be theta equals 45.2 degrees. And to make our solutions more prominent, we will highlight the answers. So thank you for following along, and have a good day.